All right, we're going to look at sections E and F today. So, trig functions of any angle. So, we've been talking about SOHCAHTOA with the concept that their definitions are sine is opposite over hypotenuse, and so on. All right, so here we can generalize that. So, let's say we have a triangle here. Okay, right angle. This is your theta. Well, this is your opposite side, this is your adjacent side, and hypotenuse. So if I want to find the sine, it's the opposite over the hypotenuse. Okay, another way you can think about it is this is an ordered pair. This is the ordered pair x, y. And then, so this distance, this adjacent side is that distance of x. The opposite side is that distance of y. So instead of opposite over adjacent, which would be for tangent, opposite over adjacent would be for tangent. And if we think about our unit circle, if we do a circle here, then your hypotenuse is the radius of that circle. So this right triangle is made up of an x-coordinate, a y-coordinate, and then that distance r, the radius of the circle. So for opposite over hypotenuse, we could say it's y over r. Okay, cosine adjacent over hypotenuse, that would be the same as x over r. Tangent, opposite over adjacent, y over x. Okay, so this is just another way that you can use your SOHCAHTOA. Okay, so here, find the 6 trig values for the angle whose terminal side goes through the point -5, 2. So if we just kind of do a quick sketch, -5, 2, we'll say this is the point -5, 2. So here's your right angle. You're looking for, this is theta, we're going to use the reference angle, this reference triangle. So we're going to use this value for our 6 trig functions. Okay, so then this adjacent side is going to be -5. So to get to this point, you go left 5, up 2. So left 5, or a length of 5, is this horizontal side to your triangle. Up 2, so this vertical side is 2. Okay, now the other thing we need to know is the length of the radius. So we're going to use Pythagorean theorem. 2 squared plus 5 squared equals c squared. It doesn't really matter whether you go a +5 or a -5. When you square it, it'll go positive either way. So c is going to be the square root of 29. So square root of 29. So now your 6 trig functions, sine of theta, cosine of theta, tangent of theta. So sine is opposite over hypotenuse, or you can think of that as your y. Your 2 is your y. Okay, so your 2 is your y, your -5 is your x, and this root 29 is your radius. So sine opposite over radius 29, you're going to have to rationalize. So this is 2 root 29 over 29. Okay, similarly, your cosine adjacent, so it's going to be a -5 over root 29. Once you rationalize, -5 root 29 over 29. Tangent, opposite over adjacent, so 2/5, and that's going to be negative. Okay, so your other 3 trig functions, your cosecant, do the reciprocal of your sine. I'm going to go back to that original statement. So when I do the reciprocal, my square root is on top. Secant, same thing. It's going to be a root 29 over 5. Make sure it's negative. Doesn't matter where the negative is. And then cotangent, would be a negative 5/2. Okay, so here's another one very similar. Given sine of theta is 4/5 and tangent is less than 0, find the other 5 trig functions. Okay, so some of these were negative, and it was because of this x being negative that we were going to the left. So that put this triangle in the second quadrant. Okay, one thing we talked about earlier in the year, all snow tastes cold. Okay, so this tells you which trig functions are positive in which quadrant. So on 16, if the sine of theta is a positive 4/3, we are either in the first quadrant where everybody is positive, or we're in the second quadrant where the sine is positive. Okay, the other piece of information we have is that tangent is less than 0, so tangent's negative. So we're not going to be in the first quadrant because tangent's positive in the first. We will be in the second quadrant. Okay, so when sine is positive in that quadrant, that means cosine and tangent are both negative in that quadrant. Okay, so we are going to be in the second quadrant. So when I go to set up my triangle, my sine opposite over hypotenuse would be 4 is my opposite, 5 is my hypotenuse. Okay, Pythagorean theorem to get the other side, or if you recognize it as a Pythagorean triple, that side will be 3. Now you can find your other trig functions. So we can go cosine is going to be adjacent over hypotenuse, 3/5, or again, oh, I made a mistake. Do you see what I didn't do? This 3 is going to the left. So that means it needs to be a negative 3. So then this is going to be a negative 3/5 for our cosine. Tangent is opposite over adjacent, so tangent will be negative. And then you can have your other 3 trig functions. So cosecant is the reciprocal of sine, so the reciprocal of 4/5 is 5/4. Secant, reciprocal negative 5/3. Cotangent, reciprocal negative 3/4. Okay, so before I leave this one, let's look at these negatives. So you'll notice cosine, tangent, secant, and cotangent are all negative. The only ones that are positive are the sine, and then consequently the cosecant would be positive also. Okay, and in your second quadrant, S, so sine is positive, everybody else is negative. Okay, reference angles. Reference angles are always acute. They are always positive. And you draw them into the nearest x-axis. So we're going to sketch in, so 300 degrees, well, this is 270. This is 360 for one complete rotation. So 300 degrees, about right there. So there's a 300-degree angle. Okay, now the reference angle, go to the closest x-axis. So this distance is your closest x-axis. Well, if we're at 300 right now, to get to 360, that's a difference of 60 degrees. So 60 degrees is your reference angle. Okay, a negative 135, so negative, this would give you negative 90. This would give you negative 180. So a negative 135 is going to be about right here. Okay, so the closest x-axis is to continue to a negative 180 degrees. So the difference between a 180 and a 135 is 45 degrees. Okay, now remember, reference angles are always positive, so it doesn't matter that we're traveling clockwise. It's still a positive 45-degree angle. Okay, C, 213 degrees. So here's 180, here's 270. So you know that 213 is going to be in the third quadrant. So 213 degrees. So since we're in the third quadrant, traveling back to the 180 degrees is going to be the shortest distance. So the difference between this angle that finished at 213 and then the 180 is, I think, a 33 degree angle. Okay, so reference angle will be 33 degrees. You can do the same thing with radians. So with our radians here, remember pi is 180 degrees. This is pi over 2, 3 pi over 2, and then 1 complete rotation is 2 pi radians. So 5/6 is a little bit less than a whole. So we're going to be right here. Now, nearest x-axis is going to pi. So the difference between the 5 pi over 6 and getting to a whole pi, this is a 1 pi over 6, or pi over 6. Okay. All right, a negative radian measure, same thing. Okay, got to kind of figure out. So if I'm going negative, this is going to be a negative pi over 2. This is a negative pi, a negative 3 pi over 2, and so on. Okay, so negative 4/3, that is more than 1. So I'm going to go negative. So I'm going clockwise. So this is a negative 4 pi over 3. Okay, your closest x-axis is traveling back to negative pi. So the difference between 4 pi over 3 and pi is a pi over 3. Okay, it's a 1/3 pi. So you think of this as 4/3, that's 1 1/3. So if I've gone past to 1 1/3, how do I get back to 1? It's a difference of 1/3. Okay. All right, so that's going to be it for today. And then we will look at special